Today we are working on 7.3, solving systems using elimination. So previously we have solved these systems of equations graphing and by substitution. Today we're going to add another part to it. So we can add or subtract equations to eliminate a variable. So just like yesterday we were trying to solve for a variable, the same thing is going to happen today. We're going to add and subtract two equations together and then get the variable by itself, and then of course use applying into yesterday's as well with going back in and substituting. So what does that look like? Here's our first equation. So we're solving by elimination using addition or subtraction. So we are going to add or subtract these two equations here to get the variable by itself to look at. So the first thing I want you to look at here is, what can I add or subtract? Can I add or subtract my x's, or can I add or subtract my y's to get them to cancel? So the first step is to eliminate the x, because a 2, and if we add plus -2, it's going to cancel. It's going to give us that 0 coefficient. So as you can see here, they took the first equation and added it to the second equation. So 2 plus a -2 gives you 0, 3 plus 9 gives you 12, and 11 plus 1 gives you 12. So we get left with 12y equals 12. So we're going to divide both sides by 12, and my y value is 1. So because y is 1, and we're looking for that order pair that solves this system of equations, we can say y equals 1, and now plug this in just like yesterday with substitution, back in and find your x. So they took the first one. It does not matter if we use the first equation or the second equation, but here they use the first. 2x plus 3y equals 11. Well, we said y equaled 1, so you can see here they substituted 1 in, distributed it throughout. We're going to subtract 3 to get 8, and then divide by 2 to get 4. Just like yesterday, y equaled 1, x equals 4, so my solution is 4, 1. You can check that. If you plug your 4 and 1 into your x and y, respectively, and get 1 equals 1 here, and she checks. Pull out, go ahead and read this, pause the video, pull out the important information. As you can see here, A represents the number of adults, S is the number of students. So the number of adults and the number of students who attended this game was 1,139. The amount collected, well, it costs $5 per adult, and really there's $1 per student. So $3,067 were collected. So using elimination, first thing, we set those two equations we just created up, and what can I cancel? Well, if we subtract these two equations, I can get my s's to cancel. S minus s gives you 0. A minus 5 gives you a -4a. 1,139 minus 3,067, and get a equals 482. So we know what a value is, so we're going to substitute a in. We said a is 482, so we're going to subtract 482 to both sides, and that leaves us with s being 657. So there's 482 adults and 657 students at this game. Is this reasonable? Well, $5 times by 482 gives me $2,410. $1 per kid student. So $1 per ticket would have $657, which if you add those two together gives you our $3,067 that was collected. So the solution is correct. Here's another example. But of course, things are going to start to get harder. So when you look to cancel here, does your x's or y's immediately cancel? No, they don't. So now we're going to have to multiply first, use that distributive property, and then add or subtract. Here, and multiply by 3, and we're going to multiply everything by 3, and we're going to get these y's to cancel. So there's no magic number, there's no nothing like every single time you're going to do. This is the piece that you're going to have to find for each equation. Find when you multiply something to get this to cancel. So our first job is to eliminate this variable. So this is, think of it as like straight across, okay? This is the first one in our system of equations. This is our second equation. So here, we're not going to do anything with this first one the whole way across. We're just taking it all the way down to the end. This bottom one is what we talked about, multiplying 3 by 3 with everything. So 3 times my first one, negative 5 gives me my negative 15. 3 times my negative 2 gives me a negative 6. 3 times a negative 14 gives me a negative 42. This kicks out to this new equation. Negative 15x minus 6y equals negative 42. Now I can go back to what we just talked about, adding or subtracting equations to cancel and solve for a variable. Well, 6 minus 6 gives me 0y. 3 minus 15 gives me negative 12. 6 minus a negative 42 gives me a negative 48. And actually, we're technically adding here. It's just across the board. So negative 6 minus 42, 6 minus a negative 6. It's going to keep flip change, make her positive. So the tricky part there is just making sure that you're continuously doing the same. Alright, I like addition, so we're going to add. 3 plus negative 15 gives you negative 12. 6 plus negative 6 gives you 0. Negative 6 plus a negative 42 gives you a negative 48. Alright, so I have solved here because this is brought over here. Negative 12y equals 48. We're going to divide by negative 12. 48 divided by negative 12, x equals 4. So because x equals 4, this is one of my equations from my system. Okay, so this was given in your system up here. X equaled 4, we just discovered. So plug 4 in for x and solve for y. We get y equals negative 3. So now my order pair here is 4, negative 3. Because this is my solution, just like we were finding the day before with solving this system, finding an order pair that works for both. You could plug this back in, 4, negative 3, and it would check. Go ahead and read this. Okay, the important information here. The number of cans of popcorn sold is going to represent P. N is going to be the number of nuts sold. So my P plus N is going to equal my 240 cans sold. $5 per can and $8 per can of nuts is going to make my total of 1,614. We need to eliminate a variable. So once again, these are my two system of equations that you had to create. What can I do here to get a cancel? So this is the unknown. This is that magic piece that you do have to find on your own. So here, I'm going to times my top row by a 5. And I need to do it to everything. Even on the other side of the equal sign, you have to distribute that 5 to everything. Because whatever you do to one side, you got to do to the other. subtract your equation. So 5 times p gave me 5p here in red, 5 times n gave me 5n, and 5 times 240 gave me 1,200. So it looks like we are subtracting. 5 minus 5 gives me 0, 5 minus 8 gives me a negative 3, and bring your n with it. And then 1,200 minus 1,614 gives you a negative 414. I can go through, solve for my n, my variable. If n equals 138, I can take n equaling 138, solve it in, and you'll get p. So if p was the number of pop cans, 102 popcorn cans were sold, and n was 138, so there's 130 cans of mixed nuts sold. Last one for the day, solve by elimination. So nothing cancels right away here in my first part, so we need to eliminate a variable. So here's my given, and now we can't even times one of these. So previously we had just times one equation by a number to get it to cancel. Things are starting to get even tougher. You're going to have to take your both and times it by something. So here I'm going to take it times 5, everything times 5, and the bottom one I'm going to take everything times a 3. We get, for the top row here in red, when we distributed our 5, 15x plus 25y equals 50. Take my 3, distribute to all of them. In blue, 15x plus 3 times 7, my 21y, and 3 times 10, 30. We are going to subtract here. 15 minus 15 gives me 0. 25 minus 21 gives me a positive 4y. 50 minus 30 is 20. I can take this and solve for my y. Y, when you divide both by 4, is going to give you 5. So my first set in my order pair, y is 5. I need to solve for my x. So wherever I found a y, I plugged it in 5. Solving, 5 times 5 is 25. Subtract 25. We get a negative 15. Divide by 3 to both sides. X is negative 5. So negative 5 is my solution. And start working on your assignment.